back to the 5 Minute Tech channel. Today we will continue understanding microservices to the series Polyglot Microservice Architecture based Full Stack Development Part 7, in which we will be talking about microservice composition patterns, the way in which microservices communicate with each other, and what are the patterns which are involved, which helps us in seamless communication between the microservices. So let's get started. So we are in this implementation, we have taken the use case of a book my board system, and this is the architecture which we are referring to, and we will be talking about all these communications which happen between different services which you are seeing as a dotted line, and what are the patterns that are involved that can be used to communicate between different services. What are microservice composition patterns? They are referred to as strategies for coordinating and organizing the interactions between the microservices to achieve specific business goals or workflows. In microservices, we split each function into processes, and functional decomposition plays an important role in building your microservices. It provides the agility, flexibility, and scalability to your application. In microservice architecture, applications are broken into smaller independent services that communicates with each other, and these composition patterns define how services can interact, collaborate, and share data effectively. So these are the patterns which we'll be talking about, starting with aggregator pattern, followed by proxy pattern, chain pattern, branch pattern, event-driven pattern, saga pattern. Then we will have the backend for front-end pattern, API gateway pattern, sidecar pattern, and the pipe and filter pattern. So first one is our aggregator pattern. In aggregator pattern, a single service acts as a coordinator, that is the main service, and consolidates results from multiple microservices into a unified response. Now it is suitable for scenarios where your client needs a combined result from multiple services, such as fetching the board details, in our case pricing, reviews in a board booking system. Simplifies the client-side interaction, reduces the complexity for the client, and it centralizes the logic. The aggregator may become a bottleneck and impact performance if overloaded. This is the next is proxy pattern. A proxy service acts as an intermediary between the client and other microservices. It handles routing, security, and cross-cutting concerns such as authentication or logging, and in this case we can see it can be implemented like an HA proxy, which is in the previous image which I showed. The use case is ideal for scenarios where access controls and secure communications are needed, like payment systems in e-commerce platform, and also if you have a TLS configuration you can use that. And advantages are enhanced security, it hides service complexity and handles reusable functionality. The disadvantages being it adds a latency due to routing and intermediary processing. The next one is chained pattern. The chained pattern microservices are organized sequentially, one after the other. Each service output is passed as an input to the next service in the chain, and the use case being suitable for workflows where the task must be completed in an order, like order processing in an e-commerce site. The advantage of this is it maintains the process order and allows modular design, and it knows where the application flow is so that it can revert back to the user in a state. And then disadvantage is a user single failure in the chain may halt the workflow, can become complex with a long chain of services, so that's the disadvantage. The branch pattern is a request sent to multiple microservices in parallel. The response are either aggregated or returned directly to the client. Now in the use case will be applicable in such systems like fetching board details, reviews, pricing concurrently for a booking system, and then it reduces the latency by leveraging parallel execution, whereas the disadvantages is a complex error handling for parallel request. The next is event-driven pattern. Now the event-driven pattern is asynchronously using events, often via message brokers. Service publishes an event, another service reacts to it, things like your RabbitMQ, Kafka and all. And the use case is ideal for systems requiring a real-time update, like sending notification upon successful booking. And then its advantages are the decoupling services, improves scalability, and supports real-time processing. And the disadvantages being the debugging and monitoring asynchronous flow can be challenging. So this is the event-driven flow. Saga pattern. This pattern manages distributed transaction by coordinating a sequence of local transactions. If operation fails, compensatory actions are triggered to revert the changes. The use case being suitable for complex transactions like booking travel packages where payment, reservation and ticket issuance are involved. Now, advantage for the Saga pattern is maintains consistency across distributed systems and handles failure gracefully. The disadvantage being the implementation of the complexity and the potential overhead. The next one is the backend for front-end pattern, in which you create the custom backend tailored to specific client interface like mobile or web. Each backend serves as an intermediary for its respective client. Useful for application which requires different functionalities for mobile and web applications, and like platforms like social media apps. And the advantage being your optimized performance and flexibility for specific client needs. The disadvantage is increased development and maintenance effort due to multiple backends. API gateway pattern. API gateway acts as a single entry point for client, managing routing, authentication and request aggregation. It's common in systems requiring centralized control like e-commerce platforms. Advantages being a simplified client interface, interactions, and provides security and enhanced control over the API usage. Now, disadvantage being a potential bottleneck and a single point of failure. The sidecar pattern runs alongside the main microservice to handle auxiliary tasks such as logging, monitoring and configuration, something which we saw in our implementation for the logging. Suitable for containerized applications where sidecar provides additional functionalities without modifying the main service. Now, advantages are being like something like promotes modularity and simplifies auxiliary task management. The disadvantage being requires additional resources and careful orchestration. Now, the last one is the pipe and filter pattern. The data is processed sequentially through a pipeline where each stage performs specific tasks on the data. The use case being you're effective in data processing like ETL, extract data, transform and load workflows. And the advantages is being enabled modular and reusable pipeline design. And the disadvantages being your processing can become slow with extensive filters. Now, all these patterns are something which we will implement in our system. This was a brief overview of how the different patterns are used to communicate in our services inside the microservices. So let's get into the demo part. So we are in the Visual Studio where we left our project last time, and here we will create one folder called composition to demonstrate the different composition pattern. We'll create a web application, web API, to demonstrate how we can orchestrate our API projects to use different kinds of composition pattern. So my web API is ready. I will just remove the unnecessary code here and go to the controller, rename this as composition controller. So let me rename this one composition. Yes. Here I have added the first aggregator pattern details on how we can implement the aggregator pattern in a simple API call. We will have HTTP client as usual. And then the way the composition pattern will come in picture is you are creating the URLs for different services for the aggregator, and you get the data for each of these services, and you do a task.whenAll for all of these services to complete, get the result and aggregate the data and return the aggregated data response. So this is a simple example of aggregation. It could be more expansive, wherein you're talking with multiple services. There is an orchestration, but this is a simple representation in an API call wherein we can consume different services and give the data as aggregated response. The next one is our proxy pattern, wherein what we are doing is we are creating a forward request method, and we have a target URL and we get the response, and then we provide the response which we get from that URL. This is the configurable service URL endpoint response which we will be using to return the data from. Next is a chain pattern. In this what we are doing is we are getting the stepwise transactions validate booking, process payment, confirm booking, send notification, and aggregating the final response. So these are all calling the different services, and on the success of each of these service, it is returning and combining the success message, else it is returning a bad request. So this is the chain pattern. So that was pretty much about the demonstration on how we can achieve all these patterns through simple implementation and also through different services talking to each other. Hope you like the video. If you like, press like and subscribe to the channel. Have a nice day.